Now we look at inequalities involving rational functions, and the same techniques that we used for quadratics work here, as long as we can factor the rational function that appears on the left-hand side of our inequality. So the basic strategy is the same. We try to move all the terms to one side. We try to factor the non-zero side, find the points where the factors are zero, identify the connected intervals between these points, and then make a table or diagram to identify where each factor is positive or negative, and then put the picture together to figure out which intervals solve the inequality, or on which intervals the product of the factor is positive or negative. So let's try to solve this inequality. 3 plus x over 1 minus x greater than or equal to 1. I'm going to transform it using step 1. And that means I bring all of the terms to one side. So subtracting 1 from both sides, I get 3 plus x over 1 minus x minus 1 greater than or equal to 0 is an equivalent inequality. Solutions of this inequality are the same as the solutions of this one. And now I have to add these two fractions, or these two numbers, to get a rational function. And this is where things get complicated, because you have to know how to add your rational functions pretty well, and it makes the problem just that little bit more complex. So 1 is equal to 1 minus x divided by 1 minus x. So I get that this is 3 plus x minus 1 minus x over 1 minus x. That's just multiplying 1 by 1 minus x here. And now that's truly a rational function on the left. It becomes 3 plus x minus 1 plus x over 1 minus x greater than or equal to 0. And that is the same as saying 3 plus 2x minus 1, so that's 2 plus 2x over 1 minus x greater than or equal to 0. And now I can factor the left-hand side, and all I need to do is just pull out a 2 there. 2 into 1 plus x over 1 minus x greater than or equal to 0. Now I need to find the points where the factors are 0. So 1 plus x equals 0 if x equals minus 1. 2 is never equal to 0. And 1 minus x equals 0 if x equals 1. Now these points split the real line into 3 connected intervals. And my next job is to identify those intervals. So I can draw a real line, put the zeros of the factors onto the line, and then identify the connected intervals in between these zeros. And remember, these points are the only points where this rational function can change sign. 2 times 1 plus x over 1 minus x, these are the only points where the graph of that function can cross the x-axis, or the function itself can change from a positive to a negative. So this interval runs from minus infinity to minus 1, the next one runs from minus 1 to 1, and the next one from 1 to infinity. And this rational function must maintain the same sign on each of these intervals. Now I look at the sign of each of the factors. So I'm on step 5 now. This is step 4. Step 5, I need to find the sign of all of the factors. And I'll put in the sign of 2 there although it's obvious that's always positive. 1 minus x is going to be negative for x bigger than 1 because I'm subtracting something bigger than 1 from 1, and then it's going to be positive for x less than 1. And 1 plus x is going to be positive for x bigger than negative 1, and it's going to be negative for x less than negative 1. And now, lastly, putting all of this information together, I can identify where the product, or the rational function, 2 times 1 plus x over 1 minus x is positive and negative. And this is using the rule that this combination of products and quotients of these factors is going to be positive if I have an even number of negative factors, and it's going to be negative if I have an odd number of negative factors. So here I have a minus times a plus divided by a plus, so that's going to be a minus, plus, 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 everything's positive, so the sign of this rational function is positive, and here we have a plus times a plus over a minus gives me a minus, so the sign's going to be negative. And now we can conclude that 2 times 1 plus x over 1 minus x is greater than 0 for x in the open interval minus 1 to 1. We're searching for the points where it's greater than or equal to 0. So I have 2 times 1 plus x over 1 minus x is equal to 0 only if one of these terms in the numerator, one of these factors in the numerator equals 0. So that's if x equals minus 1. And it's actually undefined if x equals 1, because remember this quotient is not defined if the denominator is 0. And so therefore, two times 1 plus x over 1 minus x is greater than or equal to 0 for x in the interval minus 1 to 1, including minus 1, but not including 1. And we've solved our inequality because, remember, the solutions to this inequality are exactly the same as the solutions to this inequality, the initial one, because these two inequalities are equivalent. We got from here to here just by applying the algebraic rules of manipulation of inequalities. So that preserves the equivalence, or the solution set, of the inequalities. You might want to attempt to solve this inequality. Again, you'll use the same strategy, and watch the next video to find the solution.